Welcome to the second session after a break. In this session, we'll discuss the architecture components of Azure. You will learn about the physical organization of Azure, including data centers, availability zones, and regions. We will also explore the organizational structure of Azure, such as resources and resource groups, subscriptions, and management groups. Towards the end of the session, we will delve into various compute services available in Azure. So let's begin with the initial lesson, centered around the fundamental components of the architecture. This happens to be my favorite lesson due to my passion for travel. I will demonstrate you how Azure empowers you and your data to traverse the globe, enabling resources to find their place in any corner of the world. A region is a geographical area that contains at least one data center or multiple data centers located nearby and interconnected with low latency networking. The Azure platform automatically allocates and manages resources within each region, ensuring proper load balancing. When deploying a resource in Azure, you often need to select a region where it should be deployed. Certain services or virtual machine types may only be available in specific regions. Additionally, there are global Azure services that don't require choosing a specific region, such as Microsoft Entra ID, Azure Traffic Manager, and Azure DNS. Microsoft Azure currently comprises more than 60 regions worldwide, available in 140 countries. The second term related to our regions is availability zones. Availability zones are physically separated data centers within a single Azure region. Each availability zone consists of one or more data centers equipped with independent power, cooling, and networking systems. As a result, an availability zone acts as an isolation boundary. If one zone experiences an outage, the others continue functioning. Availability zones are connected through private, high-speed fiber optic networks. To ensure resilience, each region supporting availability zones has at least 3 separate availability zones. However, some services may have limited support for availability zones. For example, some may only support availability zones for certain tiers, regions, or SKUs. Another crucial point to note is that most Azure regions are paired with another region within the same geographical area with a separation of at least 482 kilometers or 300 miles between them. This strategy enables the replication of resources across geographical zones, minimizing the risk of disruption caused by natural disasters, extensive outage, power failures, or network issues affecting an entire region. For instance, if one region from a pair is impacted by a natural disaster, services will automatically switch over to the other region in this pairing. Some examples of Azure region pairs include West US and East US, as well as Southeast Asia and East Asia, among others as mentioned on the slide. Since region pairs are directly connected and adequately distant from each other, they can be utilized to ensure redundant and reliable services and data. Besides the regular regions, Azure also offers sovereign independent regions for government organization. In other words, sovereign and independent regions are Azure regions dedicated to government entities, isolated from the main Azure environment. Azure government regions in the United States are physically and logically isolated from Azure networks for US government agencies and their partners. These data centers are operated by US citizens and undergo additional compliance checks. Azure government utilizes the same underlying technologies as Azure. This includes the services as IaaS, PaaS, and SaaS. Both Azure and Azure Government provide comprehensive security management capabilities, and upload Microsoft data protection commitments. Azure China represents a distinct sovereign region constituting an isolated Azure environment within China's borders. This exclusive Azure sovereign region in China is established through special collaboration between Microsoft and 21 ViaNet. Unlike other Azure regions, Microsoft doesn't directly oversee the operation of data centers here. Instead, 21 ViaNet autonomously manages this region. Now, let's proceed with the demo to explore our architectural landscape within the context of our global reach. Welcome to our first demo. In this demo, we will discover together Azure Global Infrastructure. For it, I will use the following website that you can see on my screen, so you can also discover it whatever and whenever you want. I will load the page and it will open me the global infrastructure experience. So what I have here, I have a 3D map of our globe that I can turn to discover different regions and geographies, as well as I have news updates related to our data centers and the legend on the left. If I open the legend, I will see different explanation of all symbols on my map. So, for example, this blue round its regions. I have also a square for zones, and even I have different sustainability projects for wind, solar, or mixed type of energy. And as well, I can open the filters to see my region according to different compliance measures or industry compliance. As well as I can discover different disaster recovery options available in each region. So if I close my legend and filters, I can turn the globe and to start seeing what are the different options available. For example, I have Central US, where I will see that this is a region with availability zones. Also, its location will be indicated as the year of opening and different products available in this region. So if I want to know more, I can just click on those options and to discover the details. For each region, I also have the data residency. So I will know that everything is stored in the United States. I will know that I have availability zones with 3 zones available, and also different disaster recovery options as cross-region disaster recovery and in-region disaster recovery. Moreover, I even have sustainability, as there is a Microsoft Circular Center coming soon. And at the end of the description, I will find different compliance standards and industry standards. So I can view them and to check that everything corresponds to my compliance needs. And also there is a link that helps me to learn about Azure compliance more in details. So it was Central US. What if we look in the center of Europe? So you know that I'm based in France, and here we are. So location is in Paris. For sure I will not find the detailed location as each region is highly secured. Also see the year of opening, different products available, and again, availability zone, disaster recovery, and compliance. If I look on my globe, we will see that Azure is a huge service because we can find it in every corner of the planet. Even here in New Zealand, we can check that soon we will have one region that is coming, and also related articles to it. What I have as well here is the possibility to switch to the map view or to come back to my 3D globe. And we have a new feature that was added, that it's a virtual tour of a Microsoft data center that you can also take from this website. So hopefully you enjoy it and you will reuse the provided link in the future to discover more information about Microsoft data centers available to you. A resource is a basic standard building block, meaning any component in Azure, everything you create, provision, deploy, etc. is a resource. Virtual machine, virtual networks, databases, cognitive services, etc. All of them are resources in Azure. We'll talk about each of those things in more details on the next slides of the session. For now, I won't explain each one in details, but I will come back to that later when we discuss their meanings. Resource groups are simply resource grouped together. As the name suggests, when creating a resource, you need to place it in a resource group. While a resource group can contain multiple resources, each resource can only reside in one resource group at a time. Some resources can be moved between resource groups, but when moved, they will no longer be associated with the original group. Additionally, resource groups cannot be nested, meaning you can't place resource group B within resource group A, and we can't create a hierarchy between them. Resource groups offer a convenient way to group resources because actions applied to a resource group apply to all resources within it. Deleting a resource group will remove all resourcing within it. By granting or denying access to a resource group, you are effectively granting or denying access to all resources within that group. When preparing resources, it's recommended to carefully plan the resource group structure that best suits your needs. For example, if you're setting up a temporary development environment, grouping all resources allows you to undo the setup all related resources simultaneously by deleting the resource group. If you need to set up 3 different ways to access the compute resources, you're creating 3 different resource groups. It's a good idea to organize the resources by each access method and then manage access at the level of these grouped resources. Now, let's examine the management structure that contains our resource groups. To do that, we'll proceed to subscriptions. Subscriptions are the unit of management, billing, and scaling in Azure. Similar to how resource groups are a way of logically organizing resources, an account can have multiple subscriptions, but only requires one. In an account with multiple subscriptions, you can use subscription to configure different billing models and apply various access management policies. Azure subscriptions can be used to define boundaries for Azure products, services, and resources. Subscription boundaries come into 2 types: billing boundaries and access management boundaries. The billing boundary of a subscription determines how charges for use in Azure in the account are applied. You can create multiple subscriptions for different billing requirements. Azure generates separate billing reports and invoices for each subscription to help you organize and manage expenses. Additionally, Azure applies access management policies at the subscription level. You can create individual subscriptions that align with your organization structure. For example, within a company, specific departments could have separate Azure subscription policies. This billing model allows you to control access to resources used by users within their respective subscriptions. So, when thinking about subscription, remember that they serve as billing boundaries and regulate access. The last architectural element I want to discuss with you is management groups. As you already understand, resources are grouped into resource group, and resource groups are further organized into subscriptions. If you're just starting with Azure, this hierarchy might seem sufficient for organizing things. However, imagine you're working with multiple applications, several development teams in different geographical regions. With many subscriptions, an effective approach is needed to manage access, policies, and compliance. Azure management groups offer high-level coverage over subscription. You group subscriptions into containers called management groups and apply governance conditions to them. all subscriptions within a management group automatically inherit the conditions applied to the management group, similar to how resource groups inherit settings from subscriptions and resource inherit settings from resource group. Management groups provide enterprise-level management at large scales, regardless of subscriptions type. Resource groups can be nested within management groups. Important fact about management groups: one directory can support up to an incredible 10,000 management groups. Also, a crucial fact is that the management group tree can support up to 6 levels of depth. This limitation doesn't include the root level or the subscription level. Within this tree, each management group and subscription can have only one parent element. To better understand the structure, let's see how we can create a resource on the portal. Welcome to our second demo. In this demo, finally, we will see Azure portal. I would like to show you how to create a resource, and for this example, I will use virtual machine creation. To create the EVM, I can use multiple possibilities. I can search it here, or I can use my menu on the left, or I can just select recently used resource that is virtual machines. I will open it, and as for any resource in Azure, I have a button with a plus to create my resource. So I will create a VM together. When I'm starting a creation of any resource, I will have a project details that will be asked, involving subscription name and resource groups. So I will select my existing subscription, and after that I can create a new resource group for this demonstration. We can call it AZ900 demo. After that we selected our resource group name, we can name our virtual machine. Also, we'll keep the same name for demonstration purpose, but if you're having doubts how to name your resources or what each field means, you can read the information provided in small boxes related to each resource. So no worries, Microsoft always helps you to learn more. So also sometimes we'll provide you the link that will bring you to Microsoft Learn if you're having doubts what is asked to fill inside. After I will select my region, I will use North Europe for example, because I'm based in France and I prefer always to use the region close to me and my user for the latency purpose. After that we have availability zones. As we mentioned before, we can have 3 availability zones, as well as I have 2 extra availability options, virtual machine scale sets and availability sets, that we'll discuss just later in this session. For the demo, I will not create extra availability options because we'll just see how to create a resource. After that, I have an image proposed here. I can use or recently used one, or recommended one, or even I can see all images accessible to me inside of Marketplace. So here I have powerful filters to search and select different VM, Windows or Linux one with different characteristics. For my case, I will just take a suggested one, and after that I will decide the size of it. The size will impact the cost, as you can see from the different proposed fields. I will go with the cheapest one for this purpose, and no worries, we'll come back again today regarding our sizes, so we'll discuss it again during our training. After that I can create a username. I will use Contoso for example, and I will need to provide a secret password for it. And after that we can select different ports. Opening, we'll discuss it more in details during our networking session. For the creation I will select just HTTPS. And no worries, if you forget to fill information about the ports, you can correct it later and we'll see how together in the next session. Also, I can provide information about the disks. I can select network that I would like to use. Also, you can see that it's creating automatically a new one for me. After that, we have management opportunities with information about the security features, monitoring one with alerts and diagnostics, advanced feature if you need some VM extensions or applications to use, and finally tags that are accessible to all Azure resources. And if I didn't specify all details about each field, it's because we'll speak about networking and monitoring and tags more in details during our training. Now just to show you how we can create a resource. And in the end, we have review and create, and we'll have a final validation of our resource creation. So if I forget something or didn't provide the correct information, I will have a pop-up window saying like I did a mistake and I need to come back and verify it. Also, I will see at the end my final price. So we will pay just for what we use. It's a consumption-based model. And I see the price for each hour, so I know how much I will need to spend for this specific VM after I created it. I can review the full information I provided to verify that I have everything filled out correctly and click on create, and we will see what will happen. As I click on create, I also have a pop-up window saying the deployment started, and after that the deployment in progress will appear. And here you will see the list of resources that will be created, their type and status. And what is the magic about creation of VM? And the fact that while we create a VM, we are also automatically creating multiple resources that just appear here. And after that, it will take approximately 1 minute to wait until everything is created and we can access our resource. Wonderful, as you can see, our VM is created. I can go to our resource, and here we are. We have all information about our VM provided. We can also modify the settings on the left side, or we can review a resource group where we have our VM. If I go to our resource group, I will see that we created so multiple resources via one resource creation. So I started the virtual machine creation, but also during this process I created my resource group, public IP address, network security group, VNet, network interfaces, and disk. And all these elements we'll discuss during our training. No worries, but it's just to show you the power of the cloud and the power of resource creation. As I created one resource, I added multiple during one task inside. Now, as we discover the portal, it was our first step in our learning of the Azure portal, let's come back to our presentation. Let's now explore different types of Azure computing. In this section, we will get to know Azure computing services. We'll explore different choices for computing, like virtual machines, app services, containers, and virtual desktops, which are displayed on the screen. We'll look at each of these resources separately in this session. So let's begin with the virtual machines, which we'll saw in our previous demonstration. With Azure Virtual Machines, you can create and use virtual machines in the cloud. They provide infrastructure as a service in the form of virtualized servers, and you can use them in various ways. Just like on a physical computer, you can configure any software running on a virtual machine. Azure Virtual Machines are an ideal choice if you need full control over the operating system, the ability to run custom software, and the integration of customizable deployment configuration. Azure Virtual Machines offer flexible virtualization capabilities without the need to purchase and maintain the physical hardware on which they run. However, within the IaaS offering, you still need to handle the setup, updates, and maintenance of the software running on the virtual machine. Virtual machines also have various capabilities that I briefly mentioned during our virtual machine creation, such as scale sets and availability sets. Virtual machine scale sets enable you to form sets of identical virtual machines while incorporating load balancing and management capabilities. Why might you opt for virtual machine scale sets? Primarily, they offer redundancy and enhanced performance. Applications often require distribution across multiple instances for reliability. As your application communicates through a load balancer, it distributes requests to various application instances. During maintenance or updates of one instance, the load balancer shifts customer requests to available instances, ensuring continuous services. For handling increased customer demand, you might need to scale up the number of application instances running your software. Azure Virtual Machine Scale Sets provide this essential management capability. They seamlessly manage applications spanning numerous virtual machines, automatically adjusting resource allocation and evenly distributing traffic. The advantages are apparent. Firstly, they're effortlessly created and managed, even for multiple virtual machines. Secondly, they offer high-tended availability and application resilience. Thirdly, they enable your application to adapt as resource needs fluctuate. Lastly, they're equipped to handle substantial scales, with some sets accommodating up to 1,000 virtual machine instances. And finally, virtual machine availability sets are another means to create a more resilient and highly available environment. Availability sets ensure that virtual machines are placed in groups that follow specific update and fault domains, preventing the loss of all virtual machines during a network or power failure. Availability set achieves this by grouping virtual machines in one or two ways: update domain and fault domain. The update domain contains virtual machines that can be rebooted simultaneously. This allows you to apply updates knowing that only a few update domain grouping cannot be in maintenance mode simultaneously. All machines in one update domain will be updated. And the second element is the fault domain. The fault domain groups virtual machines based on a common power source and network switch. By default, availability sets split virtual machines into 3 fault domains. So even if power or network fails in one domain, others stay safe. This method is cost-effective too. You pay only for the virtual machines you use. Now let's go back to the portal to learn how to set up a virtual machine scale set. In our third demo, we will see how to create virtual machine scale set and use it. So to create it, I can search or select a recent service that I use. If I use my search, I can also review the documentation provided. It's a very practical option because each documentation will bring me to the information how to use this feature, and it will bring me to the Microsoft Learn website. So if I would like to create, I will select virtual machine scale set. Again, as we did with the resource creation of our VM, we can click on plus create and provide the information as before about subscription resource group. This time I will select the resource groups that we created in our previous demo. I will also provide a name. So I will again, as in a 100 demo, I will keep it in the same region close to me. Also very practical. I can integrate my virtual machine scale set with different availability zones provided here. And after that, I can select different orchestration mode, flexible or uniform. As for VMs, I have different security types provided. I will go with default one. and I can select an image. You remember during the VM creation I go with Windows, now I will select the Linux one. We will select the sizes. Again, when I select the size, I have information about the price. And after that, we can decide how we will use this virtual machine scale set and how we will protect it. Is it password or the public key? I can, for example, go with the password. I will use the same one. Contoso, provide a secure password. Make attention that I remember it, and they're the same. And after that, we'll have multiple options as we had before for our VM. What is the most interesting for me? It's the possibility of scaling that we discussed. We spoke about different benefits, about elasticity, the automatical scaling, and about scaling itself as the benefit of cloud computing. And here we have very interesting flexibility, let's say, because we can decide how many instances we would like to have at the beginning, and if we would like to scale manually or automatically. For automatical scaling, we can select custom option and decide that, for example, I don't want that I have less than 2 instances running, and the maximum number will be 9. And after that, I will select my rules. So I can say if the CPU going more than 75%, for 10 minutes, I will increase my initial count, so my 2 instances, by 1. So we'll have 3. If I have, for example, my CPU going for 75% for 20 minutes, it means I will have plus 2 instances, so it will be 4. And also I can scale in. If, for example, my CPU is less than 25%, I can decrease my instances. I have 1. So this way I also save my cost because I don't using so many resources if I don't need them. So by activating it, it's very practical. Let's say if we have Christmas or you have like a Black Friday and you have too many visitors coming, so you can automatically increase your workload, as if you don't have so many customers, for example, Monday, you can decrease your workload. It's how we can set up this automatical scaling. And after that, if we go, we can review different policies, protection, advanced settings, and then tags. I'm not showing all these options because we will discuss them later today. So the most important, we saw how we can set up virtual machine scale set and how we can scale it automatically. And after that, we just need to create it and wait until our virtual machine scale set is created. And no worry, you can always adjust your scaling options. So it means after the creation, I can also come back to manual scaling, as I can modify the policy that I created for it. So I can modify and decide, for example, to set up 10 instances as a maximum and 1 as a minimum, and etc. Thank you for your attention. In this demo, I will not wait until it's created because we already saw what is going on. And we can come back directly to our slide as we saw together how we can deploy a virtual machine scale set and also to use automatical scaling inside. Thank you for your attention. Let's go back to the slide. Azure Virtual Desktop is a virtualization service for desktop systems and applications that operates in the cloud. It allows you to use a cloud-hosted version of Windows from any location. Azure Virtual Desktop works on various devices and operating systems, and it's compatible with applications that can access remote desktop or most modern web browsers. Azure Virtual Desktop provides centralized management of user desktop security. You can enable multi-factor authentication to secure user logins. Additionally, you can protect data access with detailed role-based access controls. When using Azure Virtual Desktop, data and application are isolated from local hardware. In fact, the desktop and application run in the cloud, reducing the risk of sensitive data remaining on personal devices. Moreover, user sessions are isolated in single or multi-session environments. When it comes to virtual machines, they are a smart choice for cost saving as they eliminate the need for physical hardware investment. However, they do have a limitation. Each virtual machine can only run a single operating system. Containers, on the other hand, offer an excellent solution when you require multiple instances of an application to operate on a single host computer. The Azure Container Instances service offers the easiest method to run containers within Azure, all without the complexities of managing virtual machines or utilizing additional services. The service falls under the platform as a service model. With Azure Container Instances, you can deploy your containers and the service will take care of launching them. The second key element on the slide introduces Azure Container Apps, a fully managed environment tailored for running microservices and containerized application on a serverless platform. This platform enables the execution of application code packets into any container, and it remains open-minded about the runtime or programming model you choose. With container apps, you harness the benefits of running containers while shedding the burdens of managing complex cloud infrastructure and container orchestration services. Lastly, the Azure Kubernetes Service, AKS, stands out as the quickest route to initiate the development and deployment of purely cloud-native applications, offering built-in pipelines that take you from code to the cloud and comprehensive security features. Azure Kubernetes Service streamlines the deployment of a managed Kubernetes cluster within Azure, elevating the operational responsibilities and shifting them to Azure. This service manages vital tasks, including health monitoring and maintenance. Quite a bit of new information, isn't it? Let's do a quick recap and compare the compute options. In the case of a virtual machine, we have a cloud server supporting Windows or Linux. A virtual desktop provides capabilities for a Windows Cloud desktop. Containers, on the other hand, offer an environment for running microservices. As for their usage purpose, virtual machines are typically used when migrating to the cloud, virtual desktop for connecting user to desktop application, and containers for scalability. Each service has its interesting advantages. Virtual machines include full operating system package. Virtual desktop can support multiple users simultaneously, while containers can reside on one operating system of the virtual machine server. If you need to deploy an application in Azure, you can first consider virtual machines or containers. Both virtual machines and containers offer excellent solutions for deployment. Virtual machines provide maximum control over the hosting environment and precise configuration. They can also be the most familiar way to deploy if you're just starting with the cloud. Containers, with their isolation capabilities and individual management of different aspects of the deployment, can also be a reliable and efficient option. It enables automatic deployment from GitHub, Azure DevOps, and any Git repository to support continuous development. Good, we have covered containers and virtual machine. Now, what's about application deployment? Azure Functions are event-driven serverless compute resources that don't require the management of virtual machine or containers. When building an application using virtual machine and containers, these resources must be running for the application to work. With Azure Function, an event triggers the function, reducing the time to prepare resources when there are no events. Azure Functions are suitable when you care only about the code for the service, not the underlying platform or infrastructure. They are used when a simple and fast action, which completes in a few seconds or even less, needs to be performed in response to an event, such as a REST request, timer, or message from another Azure service. Azure Functions automatically scale on demand, making them ideal for cases where requirements change. The Azure Function Service executes code when triggered and automatically deallocates resources after the function's execution. Azure App Service provides a dependable hosting solution for deploying applications within Azure. It allows you to concentrate on constructing and upholding your application, while Azure handles the availability of the underlying environment. Functioning on an HTTP-based model, Azure App Service serves as a platform for hosting web applications, RESTful API interfaces, and mobile backends. This service boasts multilingual support encompassing .NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. Additionally, it accommodates both Windows and Linux environments. Notably, App Service introduces the capabilities of Microsoft Azure into your applications, including security features, load balancing, automatic scanning, and automated management. Beyond that, it extends its offering to DevOps functionalities such as continuous deployment from platforms like Azure DevOps, GitHub, Docker Hub, and other sources. App Service delivers a spectrum of features, including package management, staging environments, and custom domains. These resources are dictated by the App Service plan under which your apps operate. We have reached the end of our second session. Let's recap what we have covered. We started by exploring the regions and availability zones, followed by a deep dive into resources, resource groups, subscriptions, and management groups. We then delved into various options for virtual machines, including the machines themselves, their scale sets, and availability sets. Furthermore, we compared different types of compute services, such as container instances, virtual machines, and virtual desktops. Finally, we discussed services for application deployment. With that, we conclude our second session. Thank you for your attentive participation. We'll now take a 10-minute break. See you shortly.